Okay, trig functions, and where we're going to use trig functions, especially of right triangles. So we have Sohcahtoa, and that's just used to help you remember the relationships of the trig functions. So we have sine of x or sine of theta is equal to the ratio that's made when you take the opposite side over the hypotenuse side. And remember, it's always from the viewpoint of the theta. The hypotenuse is always directly across from the right angle. From the theta's viewpoint, if you could throw a stone or something, the opposite side is directly opposite it, and then the adjacent side will always be touching the theta. But it's important to name the hypotenuse side first so you don't confuse, because they're both adjacent sides. Just one also happens to be adjacent and the hypotenuse across from the right angle. So sine is opposite over hypotenuse. So S and then O and H. That's where we get the SO. For cosine, it's the adjacent over the hypotenuse. So AH, so CAH, the CAH, and tangent is the opposite side, so that's where we get the TOA. Cosecant is the inverse of sine. So if we did, when the inverse, meaning the reciprocal, 1 over, so if we did 1 over opposite over hypotenuse, well, we wouldn't want this down here, so we'd multiply top and bottom by hypotenuse over opposite to cancel that. So that's where we get the hypotenuse over the opposite. So it's really easy to confuse these, but if you remember that the inverse of sine starts with the C, and the inverse, so S, the inverse starts with the C, and it's part of the ecants, right? Cosecant. Cosine, the inverse is secant, so C, the inverse is S. Sine, which is S, the inverse is C. Secant is hypotenuse over adjacent. Tangent, its inverse is cotangent. Those are easy to remember. And look at, those are reciprocals of each other, adjacent over hypotenuse. Where we use this information. So if we have to find sine of theta, typically it's a good idea to put the theta in parentheses. Well, notice the sine is the opposite side over hypotenuse, the SO. And what I'm going to expect to see on your papers, I want you to be labeling. Smartest thing is to label the hypotenuse always across from the right angle, the right angle, and then from the viewpoint of the theta, always label the opposite. Well, here we have our opposite side. That's 22 over the hypotenuse, which is 11 root 5. And then you're going to have to simplify, and that's always the case. If you can simplify, you must. First of all, we don't want roots in the denominator, so we'd multiply the denominator and the numerator by root 5. But notice 22 and 11, 11 goes into 11 once, 11 goes into 22 twice. So 2 times root 5 is 2 root 5. Root 5 times root 5 is just 5. You're going to do the same thing with cosine. You're going to label everything. Here's our adjacent side. So cosine theta is equal to the adjacent, which is 5 root 7 over the hypotenuse. Good thing there's no radicals, but 5 and 20 can cancel. So cosine theta is equal to root 7 over 4. Now when we get down here, sometimes you're not going to be given the sides that you need. So cosecant, which is the reciprocal of sine, so hypotenuse over opposite, and you always look from the viewpoint. So here's the opposite side. We don't know it. We know the adjacent and we know the hypotenuse. So you're just going to use Pythagorean theorem. which says a squared. So I'm going to call it the adjacent, which is a squared, plus the opposite, or the b squared, is equal to c squared, or the hypotenuse squared. Well, we want to get this adjacent by itself, so we're going to subtract the opposite squared from both sides. So that's what I did here. So 17 squared plus the opposite side, this squared, plus this squared equals this side squared. Well, we're going to subtract the 17 squareds from both sides so we can get the opposite side. So 13 squared is 169. Root 2 squared is 2. Well, 169 times 2 is 338. 17 squared is 289. When you subtract those, you get 49. Well, the opposite squared, we take the square root, and the opposite side is 7. And so now, let me move it over here. Cosecant of theta, opposite, let's see, so the hypotenuse is 13, because this is what we have, is 13 root 2 over the opposite side, which is 7. And that's it. That's all you're having to do. Over here, you're going to have to do the same thing. Secant is hypotenuse over adjacent. We know the adjacent. So look at, I just sped things up. The hypotenuse squared, subtract one of the sides, the given side squared. And then you'll simplify that, and then you'll just say secant theta is equal to the hypotenuse over the adjacent. And I want you to figure out what the adjacent is going to be and put it underneath, finish that up. All right. You're going to be doing the same thing here, but now they give you some values. Find the measure of each angle indicated. I'll go ahead and start a new video on this. All right, that's it for this one.